วัสดีครับ
สวัสดีครับ
ผมพี Audio Force ครับ
ผมเอก Audio Force ครับ
ครับผมวันนี้ทาง Audio Force นะครับได้มีโอกาสเปิดตัวสินค้าใหม่ล่าสุดซึ่งก็คือคอร์ด Mojo 2นะครับเป็นโปรดักต์ใหม่นะครับที่ผมคิดว่าทุกคนน่าจะเห็นกันหมดแล้วนะครับเพราะว่าตอนนี้กำลังร้อนแรงจริงๆนะครับคอร์ด Mojo 2เราได้รับเกียรติจากมิสเตอร์ล็อบวัตนะครับผู้ออกแบบแดกคอร์ดทุกรุ่นนะครับแล้วก็แน่นอนออกแบบ Mojo 2 ตัวใหม่ล่าสุดด้วยนะครับซึ่งวันนี้เราจะมาสัมภาษณ์คุณล็อบวัตกันนะครับเขาตั้งใจเดินทางมาที่ประเทศไทยเลยเนื่องจากเรามียอดจำหน่ายยอดจองเนี่ยมากกว่า100 ตัวภายในระยะเวลาเพียงเดือนเดียวนะครับซึ่งเป็นอะไรที่ Amazing มากๆนะครับวันนี้ต้องขอบคุณมิสเตอร์ล็อบวัตที่เดินทางมาร่วมเปิดตัวแล้วก็เดี๋ยวเราจะมีบทสัมภาษณ์กันแต่ทีนี้เรามารู้จักมิสเตอร์ล็อบวัตกันคร่าวๆนิดนึงนะครับว่าเขาเป็นใคร
ล็อบวัตเนี่ยเป็นเปรียบเสมือนเป็นพ่อมดคอยดีไซน์เป็นนักดีไซเนอร์คอยรังสรรค์ชิปแดกเนี่ยต่างๆของคอร์ดซึ่งฟาดฝีมือเนี่ยตั้งแต่โมโจ1ซึ่งมียอดขายถล่มทลายทั่วโลกน่าจะเป็นสินค้าสำหรับหูฟังเนี่ยน่าจะเป็นตัวที่ขายดีที่สุดของโลกตัวหนึ่งรวมถึงชิปแดกที่อยู่ในเดฟคิวเทสโมโจ1โมโจ2ฮิวโก้TT2 สิ่งที่ผมพูดมาเนี่ยคือเป็นสิ่งที่ขายดีมากทั่วโลกคนนี้ถือว่าคนไทยน่าจะรู้จักกันเกือบทุกคนผมไปเจอเขาที่ครั้งแรกที่มิวนิกหลายปีแล้วก่อนจะโควิดจะเจอกับแกที่มิวนิกใน2-3 ครั้งแกเป็นคนอัธยาศัยดีก็เดี๋ยวเราดูบทสัมภาษณ์เขาครับว่าเขาจะให้ความรู้เราได้ประมาณไหนกับ Mojo 2ลองดูครับ
ขอบคุณครับ
Audio is my passion. What I want to do is to be able to enjoy music. So musicality, being able to enjoy music, getting emotional when you're listening to music is the thing that drives. So what I'm trying to do is to improve the musicality. When you listen to a product, does your spine tingle? When you're listening to the music, do you enjoy the music? Do you want to listen to more and more music? And that's what I'm trying to maximize. And as an engineer, when I see that I, intellectually solve a problem, get the better improvements, then I want to make those improvements ripple down into cheaper products. I'm not a businessman. I don't care whether we sell 10,000 Mojos or 1 million Mojos and whether that will impact sales of Dave. I'm not interested in that. What I want to do is to have the maximum number of people being able to enjoy their music more. If I can see a way of improving something, then I'll really want to do that. The issue that I had with Mojo was, or the improvements with Mojo, was actually nothing to do with the technical ability of being able to improve the product. The problem we had with Mojo was that it's physically a very small size. Within that package dimension, unless you're using a fan, you can only dissipate around 2.5 watts of power. So some of the issues that we had with the original Mojo was when you were listening to it and charging at the same time, it would get too hot. So I needed to solve that issue. You were limited to around 1.8 watts when you're operating it. It meant that I had to throttle down on the FPGA. So the FPGA, I only used a third of the FPGA resources in the original Mojo. Because if I used more FPGA, it would get too hot, and you certainly couldn't be able to charge and run it at the same time. So the problem of getting better performance with Mojo 2 was about power dissipation. And I spent a lot of time looking at every single part of the circuitry, particularly the analog section, with the way the relays were being controlled and the way they were being powered. So improving the efficiency of operation. And I saved some 300 or 400 milliwatts. And also as time has gone by, batteries gotten more capable. So we've got about a 9% improvement in batteries. And that meant that I could actually improve power dissipation of the FPGA. Now, instead of using 33% of the FPGA, I'm using 98% of the FPGA. And our power that I'm using is actually less than it was before. So the FPGA is creating a lot more power, using up more power, but the overall package is less, so the thing actually runs. The other benefit that I had was that I could improve the charging circuit, design my own charging circuit that was intelligently driven by the FPGA, and that meant that the efficiency was much better. So now you can charge it and listen to it and it won't get hot. Being able to do those improvements, that was the key question. Use the same technology that's in Hugo 2, we can actually put that in there. Okay, so when I was discussing this with John Franks, what we wanted to do with it, he wanted to add the crossfeed function. I really love crossfeed. Whenever I use headphones, I always use crossfeed, and not having crossfeed available on Mojo was something that I really was pushing for it anyway. The other big thing was that we wanted to get rid of the coupling capacitor. So there's one single coupling capacitor that comes from the pulse array output of the DAC connecting to the amplifier. And there's one amplifier within my designs to make it really simple and very transparent. Downside to that is that the coupling capacitor adds a lot of warmth. And with the original Mojo, I wanted it to sound warm because you're using it with headphones that might be too bright. So if we were going to make it more neutral sounding, more like Hugo 2, then the problem is that won't suit a lot of transducers, won't suit a lot of headphones. So I then started to think we need to be able to put in a way of improving the sound quality, make it sound warmer if you're using bright headphones. And that led to the idea of putting the EQ inside it. Downside to using EQ is that it's not transparent. So if you use a 64-bit PC and run the EQ with it, so one thing you could simply do is use a graphical equalizer, increase everything by 1 dB, reduce your volume by 1 dB. When you listen to the change, things don't sound the same. Even though it's still completely flat, it does not sound the same. It sounds flatter in the soundstage, the detail resolution is worse, and timbre variation is much worse. Things are a lot brighter as well. And I've designed DSP cores for EQ before in the past, so I was well aware of the issues. So what I wanted to do was to design a completely transparent or a lossless DSP. And that was a really interesting development intellectually, because having set myself the task of designing something that was perfect from a transparency point of view, this was much more difficult than you would have expected, or I would have expected. And I ended up using 104 bits and, more crucially, noise shaping the internals of the DSP. So it's a very much more complicated DSP than you find normally, but when you listen to it, it's much more transparent. And I've actually been really pleased with the way that the forums have been reacting to Mojo 2, in the sense that people really love the sound of the EQ, and that you can change the EQ and it doesn't degrade the sound quality. The issue with WTA, the primary problem that digital audio has got is reconstructing transients. And transient is when a note suddenly changes. So if you blow a trumpet, the initial part of blowing the trumpet, that's a transient. If you strike a guitar string, when you pluck the string, that's the transient. Problem with digital is the timing of transients. And the brain uses the timing of transients to work things out. So left to right, for example, lateral soundstage imagery, that's down to the timing difference between the left ear and the right ear. Timbre variation. If you remove the transients, it becomes difficult to determine the sound of a piano against the sound of a trumpet, for example. Bass definition. Ear is very poor at bass. It's not very good as a transducer. And the brain looks at the transients of a bass guitar to determine the pitch. So pitch, timbre variation, instrument separation and focus, all these things depend upon accurate timing of transients. And if the timing of transients is wrong, the brain gets confused you can't hear the timbre, you can't hear instruments being separate, you cannot follow the bass line. So all these things really upset your ability to get emotional with the music. So the problem is being able to reconstruct the original timing. So with digital audio, 44.1 kilohertz, you have one sample, and then 22 microseconds later you have another sample. And what the DAC has to do is to work out what's going on in between those two samples and to reconstruct the timing of the transients so that it recovers the original information or doesn't distort the original information. Does this with the interpolation filter. The problem is that the interpolation filter, to be able to reconstruct the timing perfectly, you need an infinite amount of processing. And that infinite amount of processing means an infinite number of taps for your FIR filter. So it's something you physically cannot do. Difficulty is when you use the number of taps. A tap is how you define how well the filter works. The number of taps that you normally use is about 128, something like that, 6428. And that is inadequate to be able to reconstruct it properly. So when the transient comes through, it'll be a little bit too early or a little bit too late, and it'll be constantly modulating backwards and forwards. And it will depend upon what's happening in the future and what's happening in the past on this modulation. And this modulation of the transients upsets the brain's ability. So what I do with the WTA is there's an awful lot of processing going on. So we've got 40 DSP cores per channel within Mojo 2, over 40,000 taps in the filter, so it's a much more capable than normal filters. And it reconstructs the timing of the transient, so this modulation that you get is being minimized. Of course, it can't eliminate it. You need something like an M scaler. Even an M scaler doesn't eliminate it, it just makes it better and better. But there are other aspects to the way the WTA filter is put together, the filter recipe, if you like, the algorithm. And my algorithm is unique in that it's trying to reconstruct it as accurately as possible with the limited number of taps that you actually have. So that, of course, the whole part of Mojo, everything inside the FPGA, is being custom coded by myself. What that means is that I've got complete control over the input side right the way through to the output. So the whole path is under my control, and that's where the benefits of custom coding comes in that you've got that complete flexibility and control. I was talking earlier about reconstructing transients and the importance of getting transients to be completely accurately reconstructed. The problem with MQA is that it destroys transient information because the process has 1% worth of aliasing distortion. Aliasing distortion degrades transients. What it does is that it makes, when you lose transient accuracy, it makes the bass sound soft and bloated and fat and unnatural. But some people, when they hear that, they think, oh, that sounds better because my bass is big and fat, but it's inaccurate. So that's the reason we do not support MQA, because it is a distortion generating technique that changes the sound quality. I want to get back to the sound of live unamplified instruments in a real acoustic. And to do that, you cannot go down the MQA approach. Of course, if you have got an MQA recording, you can decode it in your source. So not having the decoding available in Mojo 2 is not a disadvantage. But no, MQA is fundamentally the wrong way to go forward. It's complete opposite to what I'm trying to do. Absolutely, yes. I mean, we were surprised how many Mojos were used 24/7 within audio systems, normal audio systems. I suppose we shouldn't have been surprised because the performance of the DAC side of Mojo was so good and that it outperformed units costing many times that don't use my technology. So we shouldn't have been surprised, but a lot of people were using it in fixed systems as a regular DAC. What I wanted to do was to enable that fully so that when you plug in the charger and you run it full time, it means that the battery gets completely isolated. So you can use it in a desktop situation permanently and the battery won't be used. So that's simple to say, but then that causes problems because the battery itself is part of the power supply. So for me to be able to do that without it sacrificing sound quality meant that I had to improve power supply regulation within the analog section of the DAC of Mojo. This is what I did so that there's separate regulation so it doesn't rely on the clean power that the battery supplies. It's completely regulated. The previous Mojo was not regulated, it fed directly from the battery. So it relied on the battery being there, although it could work without the battery being there. This one has been designed so that it doesn't need the benefits of the battery because it's got the added power supply rejection and the added regulation. So when you plug it in and you use it 24/7, your battery won't disappear, it'll just be completely isolated. It won't be trickle charged or upset. So the battery life is still preserved. Oh, that's only for use with an M scaler. So my dream is to be able to have an M scaler with this size and a portable device. To do that, you would probably need 3 nanometer FPGAs, which is probably 10 years away. But one day it will become available that we will have a portable M scaler. Then you could plug that in. When I was doing my listening tests for Mojo, I was always using an M scaler because that's the best way of getting the best possible sound into the device so I could test it that way. So the reason we've put the dual port in there is that it costs nothing, costs a little bit in power dissipation, but that's not a problem because I'd solved that issue. But it gives you the flexibility. I don't expect people will use an M scaler with a Mojo, but you might do. But what I do expect is as the years go by, we will have M scalers coming in at lower prices, or perhaps we'll have something a little bit simpler than the M scaler in a smaller package sometime in the future. So these are things that will happen. It's just a question of whether it's going to be in 2 years' time or 10 years' time. That's the only question. So I wanted it to have that ability. And since it didn't cost us anything to do it, apart from a tiny amount of power, it was an easy decision to make. The best thing to do is to try it for yourself. To go to your dealer and have a listen. If you're buying online, then most online will be able to, you'll be able to demo it yourself and send it back. But the thing to do is to listen to it yourself. That's always my recommendation. Go to your dealer, listen to it, try it yourself. If you love it, buy it. If you don't, try something else. I'm producing things that I believe in, that makes me emotional, that gets me engaged in the music. I think that will work with other people. I know it will work with other people, but everybody has their own tastes and they should try it for themselves. Thank you, it's been a pleasure. And I must say it's great to be back in Thailand.